Black holes, some of the most mysterious and powerful objects in the universe, can collide and merge in dramatic cosmic events. When two black holes orbit each other closely, they gradually spiral inward due to the emission of gravitational waves, ripples in the fabric of spacetime predicted by Einstein's theory of general relativity. As they draw closer, their speeds increase, and eventually, they collide and merge into a single, more massive black hole, releasing an enormous amount of energy in the process. The detection of these black hole mergers has become possible with the advent of advanced observatories like LIGO and Virgo, which can measure the subtle distortions caused by passing gravitational waves here on Earth. Since the first confirmed observation in 2015, numerous black hole collisions have been recorded, opening a new window into understanding the universe's most extreme environments. These observations provide valuable insights into black hole masses, spins, and the nature of gravity itself. Such cosmic collisions not only reshape the black holes involved but also influence their surrounding environment. The merger releases energy that can affect nearby stars and gas clouds, sometimes triggering bursts of radiation or other dynamic phenomena. By studying black hole mergers, astronomers gain deeper knowledge about how these enigmatic objects grow and evolve over time, helping unravel the mysteries of the universe's dark and dense corners.